Okay, so let's take a look at a few example problems using the ideas of circumcenter and incenter that we just learned. The first one says that the perpendicular bisectors of triangle ABC are segment PT, segment QT, and segment RT. So let's just highlight those real quick. We said segment PT, segment QT, and segment RT. So those highlighted segments there are our perpendicular bisectors. And what that means is that this point T, oops, I didn't mean to grab my highlighter, I wanted my marker. Point T there is our circumcenter, right? That is the circumcenter of our triangle, which means that it's going to be equidistant from all the vertices of the triangle. So, from T to B, this guy right here, from T to C, this guy right there, and from T to A, this guy right here, those distances should all be the same. So if it asks us to find RC, well, let's look at that. RC is actually not one of those segments we just talked about, right? Segment RC is right here. So how does all this information help us find segment RC? Well, it comes back to the idea that segment RT, this guy right here, is a perpendicular bisector of our triangle, which means that it's coming down, it's making a right angle with one of the sides, but it's also bisecting that side. So if segment RT is a perpendicular bisector, it means that segment AR and segment RC are going to be the same length, right? So segment RC would be a length of 5. Now in the second example, we have the same setup, the same information, same picture, but now we're looking at finding the length of AT. We're looking at this segment right here, trying to figure out how long that is. Now, just on the other page, I said that point T was our circumcenter, so we knew that it had to be equidistant from the 3 corners of our triangle. You'll notice that we already know the length of segment CT. It's 6 units. So that would mean that every segment that's going from the circumcenter out to a corner, so from T to C, from T to B, from T to A, all of those should be 6 units, so our length of AT would be 6. So AT equals 6. Now in this next problem, example 3, now we're looking at angle bisectors. It says 2 of the angle bisectors of triangle ABC are AP, so segment AP, and segment BP. Those 2 things are angle bisectors. And so that means that they're intersecting at P, which would be P would be now the incenter of triangle ABC, which means that P will be equidistant from the sides of triangle ABC. All right? Point P will be equidistant from each side of triangle ABC. I forgot the C on the name of the triangle there. So the first thing it's asking us is to find the length of PK. Well, if I look at P, if I look at where point P is there, I see that from P to J, that segment is a perpendicular segment to segment AB. Now angle BAC is one of the angles that got bisected, right? It got bisected by segment AP because it says it's segment AP is an angle bisector. So segment BAC is getting bisected. Point P is on that angle bisector, and it's going to be equidistant from this side and this side. Okay, good enough. That would tell us that the length of PL would be the same as the length of PJ or JP. So that would be a 5. But then if I look at this segment, segment BP, it's also an angle bisector. So segment BP bisecting angle ABC, which means that point P, again our incenter, will be equidistant from the 2 sides of angle ABC. So we already know that it's 5 units away from this segment AB. It's also going to be 5 units away from this segment, segment BC. So that would tell us that the length of PK would be 5. Now on this last problem, again, same picture and same information as our example 3, but now we are supposed to find the perimeter of triangle APL. When we do the perimeter of a shape, we're adding together the side lengths of that shape. So to find the perimeter of triangle APL, we're adding the length of AP plus the length of PL plus the length of AL. If I look at my picture, I already know that the length of AP is 13. All right, so I can put 13 in for the length of AP. I already know that the length of PL is 5. I talked about why on example 3. Since P, well, just to recap here, this is an angle bisector for angle BAC. Point P is on that angle bisector. Point P is 5 units away from one side of that angle, so it's got to be 5 units away from the other. So that's how we know that the length of PL is 5. What we're missing here is the length of AL. All right, we're missing the length of AL right there. But here's what I want to do. I want to concentrate for a second on this triangle right here, triangle APL, the triangle that we're kind of dealing with here. I'm going to redraw it down here. We got point A, point P, point L. I know that this is 13. I know that this is 5. What I also know about this triangle is that it's a right triangle. All right, this angle right here has to be a right angle. I see in the picture that that right angle is actually over here, but we know that if that's a right angle, so is this one right next to it, because we got a straight line here that's going to be 180 degrees. If 90 degrees is here, 90 degrees will also be here. So we got a right triangle here. This is one side of a right triangle that we don't know, but we do know the other two sides. And so what that means is we can use the Pythagorean theorem, a squared plus b squared equals c squared, and we can use the Pythagorean theorem to find this missing side down here. So when we use the Pythagorean theorem, we have to remember that C is always the hypotenuse across from the right angle. So the 13 is going to be our C. The other two, A and B, are the two sides. So this could be A, and we could say that the missing one is B. So we can say that 5 squared plus B squared equals 13 squared. So 25 plus b squared equals 169. That's 13 squared. We're going to subtract 25 from both sides. B squared is 144. And now to find the length of B, or the length of AL in this case, we are going to do the square root of 144, which is going to be 12. And so the length of AL, we now know, is 12. And the perimeter of triangle APL is 13 plus 5 plus 12, which is going to give us 30.